Are you ready?
Here's a quick illustration how you can test a diode with an analog meter. I've got it on R times 1, and if we read this way, see it doesn't read. If you read this way, it reads. So as you can see, this line is on the negative lead. Positive lead, it can flow through that way, but not this way. Now if you have a digital meter, it doesn't work nearly as good. I think that analog meters must push a little more current through, and it really works well. But digital meters, you're going to see it read both ways, and you just kind of have to make a decision as to which way it reads more or less.
It took decades to perfect the process of producing silicon with a perfect monocrystalline structure. They begin with raw polysilicon, or poly, and heat it to over 2,500 degrees Fahrenheit inside a special sealed furnace, which has been purged with argon gas to eliminate any air. The resulting lake of molten silicon is then spun in a crucible, and a silicon seed crystal, roughly the size and shape of a pencil, is lowered into it while spinning in the opposite direction. As the molten polysilicon is allowed to cool, the seed crystal is slowly withdrawn at around 1.5 millimeters a minute. The result is a single silicon crystal weighing around 440 pounds and with a diameter of around 200 millimeters. The crystal is so strong its entire weight can be supported by a single thread just 3 millimeters across. But it is brittle, and it must now be cut down to size without shattering. After testing with chemicals and X-rays to check its purity and molecular orientation, it's fed to a silicon salami slicer. This 10-ton wire saw uses a fast-moving web of ultra-thin wire to produce wafers of silicon that are just 2/3 of a millimeter thick and 99.999% pure. Once cut, there are microscopic marks left on the wafer's surface, so it's time for a buffing using a process called lapping. After a twirl in this high-powered polisher, they are still not smooth enough. So they're given yet another buff using a chemical process. The result is wafers of silicon with a surface roughness of less than 1/1,000,000th of a millimeter. Buffed to a sheen, they're finally ready for etching with the circuit designed.
is founded by China government with 40 years experience to produce rectifiers. Planar process with the uniformity of electrical field of the terminal ring for stabilizing the withstand voltage of the diode, which means the lower leakage at said reverse voltage compared to GPP. Planar sustain higher junction temperature. Lower forward drop.